happy to be here. As you heard, I did move to Costa Rica 6 months ago, and common question I get from friends and family is, what's it like living in Costa Rica? And I have the same response. I get to brew fresh coffee versus Folgers every morning. I sit on a hammock, and about 6 o'clock, whales and dolphins breach the ocean. And I wait a second, and I say, I wake up from that dream. I usually spend my time looking at the back of car bumpers as I sit through traffic, but what I did realize was I just went through the harsh winter of Costa Rica over the last 6 months, a low of 68 and a high of 80, and when I arrived back in Kentucky for Christmas, and it was 28, I decided I may never move back. So I'm going to talk a bit about this area that we call this innovation incubator. And under this innovation incubator, we're focusing on this topic of microbes. And microbes aren't always a pretty topic and are mostly forgotten. But just sitting back there over the last 2 minutes, maybe it's perfect timing, but Scientific America released an article, Microbes Could Boost Crop Production. And it fits in perfectly with what our goal and strategy is and some of the things we're doing to look at microbes for crop production, but also in the area of disease. But this innovation incubator, it's how Alltech guides our research programs. So we discover what's the problems. From a crop side, I can tell you right now, we have 2 crop programs in this innovation incubator for Alltech, greening and black Sigatoka, which is in Costa Rica. We innovate. What technologies do we have, or do we think we have, or can we come up with to try to solve some of the issues? Maybe it's a group or a collection of technologies. And we go to the deliver stage. What's it take to get this evaluation going, even if it's a plane ticket to Costa Rica or a trip to some location or a person moving? That's our strategy. So discover, innovate, and deliver. Alltech Research and Alltech in general, for those that know us, we're 35 years old, and our whole focus over the last 35 years has been in this area of microorganisms, fermentation, and natural nutrition, and that's for both the animal and the plant side of our business. But through the 35 years, we've focused on bacteria, yeast, and fungi. And we began several years ago looking at this area of microorganism and plant partnership. What's going on in the soil? What's going on if we were to add additional microbes to the plants? And we've always seen we could spend 2 or 3 days looking at this relationship in a conference. It's fairly common, but improving nutrient availability, providing disease resistance, and also helping to reduce environmental stress, especially high drought conditions. 1 teaspoon of soil, there's a whole world of living organisms, over 1 billion bacteria, fungi, algae. And we've always seen this relationship between plants and microorganisms, in this case bacteria, which fixes nitrogen in the soil, providing more nitrogen for this soybean plant. And we ask ourselves often, are we helping or hindering this relationship between the bugs and the plants? And we've definitely become, out of necessity, what we might call this pesticide planet. We're forced to use these chemicals because we don't have alternatives that allow us to completely cut it out. In some parts of the world, especially Costa Rica, being one of the highest users of pesticides out of necessity. And over the last, from 2000 to 2015, the trend continues to rise. North America actually has shown the lowest growth of the use of these various pesticides. And you have places around the world that say we don't want any more chemical inputs, but we want to find some other alternatives. Kiwi fruit disease in New Zealand, they want a variety, let's change variety that's resistant. French winemakers demand action on incurable grape disease. Italy's olive trees, just a few examples of some of the similar situations that we're facing here. What can we do to treat these diseases? And can we reduce our dependence on pesticides before it's too late? And we think we can do some things with this world of microbes. Again, really focused here on this area of pathogen and disease resistance. So we know about 2% of the bugs that we walk on a daily basis, and 98% we have no idea what's in the ground. We are building an all-tech crop science research facility in Ireland, and part of that facility is to focus on what's happening in this 98%. And this article just came out a few minutes ago. Major companies are focusing on what else is in the ground that we can benefit from. 25 new antibiotics from one sample of soil dating back 1987. And maybe soil's much more interesting, more of pay dirt. But this area of microbial business is definitely growing over the next few years, doubling. North America seems to be leading the way of interest in utilizing microbes and adding microbes and getting the most benefit of the microbes that's in the soil. And you see this breakdown of soil microbes. About half of it's a bacteria and half of it's a fungi. And we know bacteria plays many roles: fixation of nitrogen, suppression of soil-borne pathogens, and most importantly also plant nutrition, along with the production of antibiotics, which again inhibit some of the growth of some of the pathogens that we don't want in the soil and in the plants. And when we feed the soil, we're feeding this bacteria here called rhizobacteria. That's around the roots, and Ed will get a little more into that in a few minutes. But that's the area we're focused on, because these bacteria provide amino acids, nutrients, and stimulate the growth of the plant. And then you get into this fungi, soil fungi, and we know what we see in the degradation of organic matter, plant material in forests, and it's the same that's going on in the soil. Breaking down material, releasing more nutrients, competing with plant pathogens. But we also see, for example, in this tomato plant, this is a fungi wrapped around the root of the mycelium of the fungi wrapped around the root. So you pull out this plant, and the roots are 6 inches. But this mycelium extends another 8 or 10 inches, and what that's doing is going deeper in the soil, and that's pulling up water. That's the way it works, so pulling up water and nutrients that's not available to the soil. So we produce fungi in this facility here. It's about the largest in the world, and we produce fungi that's beneficial for both plant and animal nutrition. And now we get to this area of saving the banana. So those that have heard of our owner, Dr. Lyons, he travels the globe every quarter. And he goes into Asia and Latin America and North America, and he asks the questions to producers, what's your problems? And that's how we come back and look at this innovation incubator. And he went to Latin America, and this was the problem. A disease that's ravaging the industry. So about April or so, or March, we put this in our program and we started researching it. We put a team together, and we thought we had some interesting things, but you can't do a lot for banana in Lexington, Kentucky. So I tell this story because this is how it plays out with him. It's a Monday morning. He says, why don't you move to Costa Rica? And I completely ignored him. Didn't even say I'll think about it. I can't speak Spanish, and I know nothing about bananas. Tuesday morning, phone call, why don't you move to Costa Rica. Have you thought about it? I completely ignored. Didn't even say no. Tuesday afternoon email. I need a decision on Costa Rica. So I go home that evening and ask my wife, and I said, what do you think if we move to Costa Rica? And her exact answer is, I'll start packing tonight. So I call him, and the rest is history. We moved to Costa Rica. So just a little idea of the agricultural industry in Costa Rica. Coffee, rice take up the most acreage. Bananas around 100,000 acres. And Costa Rica is the largest pineapple exporter in the world. And they've got about a 50,000 orange citrus production. If you look at what drives Costa Rica, it's actually IT, Intel, and computer technology is the main. But out of the gross product, almost 5.5–6% is banana. So it's a major industry for them. 110 million boxes, 10% of the world's exports. And it creates about 100,000 jobs for Costa Rica with a country of 4 million people. And if you look over the last, from 2002 to 2014, they maintained fairly steady production of boxes, 110 million this year. Their boxes per hectare over the same time period, 2002 to 2014, have remained similar, 2,500, 2,600 boxes per hectare. And then if you look at total hectare acreage, 2014 they were 42,000, so let's say 98,000 acres, and they'll hit 100,000 this year. But the big problem is this disease of black Sigatoka. It's a fungal disease, whereas we're dealing with bacteria here. They have a fungal disease, and it's airborne, so the wind blows it from leaf to leaf to tree all across the country. And the economic impact is they've seen about a 50% yield loss if the trees are left untreated. Major increase in production, 25% inputs, and it has essentially shut down small farm production of banana in Costa Rica. The 3 or 4 big international companies are all that's really driving down there currently that have the money to fight the disease. And if you look at a banana in a retail setting, a third of that banana is from fighting this black Sigatoka disease. So they've come up with programs. These are government standards, standardized control measures for national and regional. So what they're trying to do here is get the banana producers in the south and the north to fight this at the same time so that they're not blowing spores from one place to another, and hopefully they're cutting down. Cultural practice, the same as we've just heard earlier, what you're doing here, focused on nutrition, better disease resistant for the plant. De-leafing, this is what I call a haircut for the banana trees. They simply begin cutting where the disease is at until there's no leaf left. And once there's no leaf, there's no future banana production. And this fungicide by arrow application, that's the major issue. But they're also looking at resistant cultivars. And lots of groups down there growing types of bananas, but from a taste standpoint, no one in here would eat them. But this fungicide of arrow application, this is a plantation that we're working with down there. Let's say 10 years ago, roughly, you would treat that 100,000 hectare about 3 times a year with fungicides. Now they're about 60 times a year. The resistance of this black Sigatoka fungus to fungicides is up around 60 to 70%. So they're spraying on a daily basis, and they have to in order to have a banana crop. And but the problem has come as the government, Costa Rica government, says a mandate reduction of 20% in the next 4 years, and it gets higher. So the industry, the growers and producers have to find alternatives to some of these chemical inputs. And that's where we looked at an opportunity. We started the program in Kentucky back in March, April, looking only at a lab scale. But we moved to Costa Rica and we built a lab. And our reasoning for this is so that we can work, and we're working with the top folks in Costa Rica, Corbana, which is a national banana co-op they've got a great research program going on down there, and the great thing is they're focused on this area of microbes as well. They see that as the future for reducing some of these chemical inputs. But by having a lab here, I can work like as I do with the producers on a daily basis. We can try producing some things here, and we can get it in the field in the next week. And that's the objective of why we invested in this facility. We built some fermentation equipment, which allows us to grow the bugs up. And all that we have to do next is get in the truck and drive and get some applications started. So here's some things we've done since my arrival. We always hear a lot about bacteria and fungi, and we have 3 here. We've labeled A, B, and C. I probably screened 70 different bacteria, and I found 3 that showed to inhibit. So you can see this control, full growth, and we saw some inhibition. This is a different form of the fungus in the country, and we saw inhibition. So these 3 bacteria out of 70 produce some form of metabolite or toxin or antibiotic, however you want to term it, which broke down and stopped the growth of this bug. So that's great from a lab standpoint, but next we moved into field trials. So I moved on the 20th of July, and we started our first field trial on July 31st. And that went through actually the first week of November. And what our goal was is to look at our technology that we produced and reduce fungicide by 50%. And that's stretching, but our whole goal was to see if we had any impact at all. So all these different treatments, no control, this T2 is the commercial treatment. We let them do exactly what they would normally do. And the rest, we used our technologies by swapping. One week we'll spray our technology, next week the fungicide. So we reduced 50%. And I know it's hard to see in the back, but this graph is the total number of leaves on a plant, and leaves equal banana production. So if this bottom line here was no treatment whatsoever, and you can see that the number of leaves as the disease took over dropped. Essentially they're cutting them because they just die and wilt away if you don't do anything. But if you look at the very top here, this solid circle here and those top, the solid circle is standard commercial fungicide treatment. And the top 2 lines is the 50% reduction utilizing some of these technologies we've developed. So it's quite interesting. We weren't sure where we would be, and we never claimed we would be better, but we're at least equal as at this stage to the standard treatment. So this is the percentage of disease occurrence, and this very top line is no treatment, and you can clearly see that the disease has taken over the tree. Again, the very bottom line as we drop here, we're right equal with the standard commercial treatment. And this has led to quite a bit of excitement with some of the producers down there. And beginning next week, we've got a complete new program scheduled with moving into higher acreage and more spraying by reducing. And I always tell this is an interesting point because I don't know the rainfall in Florida, but I know in Kentucky. But over the course of this 4 months, we had about 90 inches of rainfall on these bananas. And that's what leads to the problems. Rainfall, humidity leads to fungal disease and fungal growth. So and you can't control climate. So here's a leaf with no treatment. Here's a leaf with treatment. So you can see that the disease isn't spreading nearly as rapidly as without. But there's a crisis looming in the banana industry, and it's a new fungal disease called Fusarium race 4. Fusarium is a disease in soil as we speak in lots of crops. Fusarium race 1 is in bananas, and it's very treatable and curable, but race 4 is no treatment at this stage. It's not in Latin America, it's all in Asia, Australia, some of the main banana producers. But there's a terrified sense that when this disease hits Latin America, the banana crop will be gone as we know it. And it doesn't just wilt a leaf. This disease completely destroys the tree trunk of the bananas of the trees, and the tree dies. These are headlines from October, CNN, Fox News. Why bananas as we know them might go extinct. A new study confirms that bananas are going extinct. A fungal disease is wreaking havoc on the world's favorite fruit. So there's a major fear in the banana industry, as there is in the orange industry, of if we don't get a hold of some of these diseases, maybe the top two fruit production of citrus and banana could very well be in trouble, if not gone. So Costa Rica and Latin America is taking some steps, desperate steps maybe, but this Banana Congress has always been in Latin America, Central America. And this year they've moved it to Florida, Miami, to prevent folks from Asia traveling into the country, afraid they may bring the disease on them. And this is a large conference, about 1,000 people, and it's the biggest, it's all the producers globally attend this. So I tell the banana story for three reasons. One is that it shows that what we implement with this innovation incubator that we have in place, we find the problem and we move on it. But I also believe that what we're doing in Costa Rica, setting up the lab, could have some impact as we at Alltech helps in this area of greening. Because I don't think there's going to be a silver bullet, but I think there's going to be a combination of all the solutions that can help slow, and we as hope cure some of these diseases. And even you look at citrus greening, and everyone in this room knows better than I do, but great sums of money going into finding cures from a federal standpoint, and even more from a private. And we're looking at lots of alternatives and using some of the pesticides that's never been used on citrus, and then we get worried of what it might be doing to honeybees. And then the big question, do we focus on this bug or do we focus on this bug? Or do we focus on the tree? And we see that before the leaves are infected, greening starts to infect the roots. And we ask ourselves, what's the solution? And it's certainly going to take outside the box thinking. I've seen that in the 3 days I've been here, and it's great that something will be the solution or multiple solutions. Fermentation capabilities. I believe what we're doing in Costa Rica on some of the microorganisms has put us ahead of the curve for when we start tackling some of the greening, when we start growing this bug. We're ahead of the curve because we already know what some of these bugs do in terms of inhibition, and I'm quite confident that we're going to be able to move faster due to what we've started in Costa Rica. Plant nutrition, it's already been discussed clearly. The healthier the plant, the better it is to fight disease. And culturing this bacteria, that's been a difficult challenge, and we're confident that we have the capabilities to culture the bacteria. We've spent Alltech's a fermentation-based company, and we've got a lot of support and help in terms of in this area of microbes. So we've got a lot of effort and support behind this biological development program, looking at microbes to inhibit, hopefully stop or cure some of these diseases. But it's going to take research, and it's going to take the producers working together, and that's what we've started in Costa Rica, and that's what we're starting here in Florida. So some of the solutions, innovation, we have to provide something. We have to move quickly, speed, and we have to implement, and that's our goal. What can we pull together from a greening standpoint, from innovation, but how fast can we start doing some testing and getting it implemented? Now I'll leave with this, the one conference that we have in May, because it's a complete conference for the agricultural industry. We're going to have topics, dialogue, discussing what's impacting both animal and crop industries, and greening's on the agenda. Sigatoka, the banana disease, is on the agenda. There's a disease that's wiping out palm oil in Asia. So we, as an agricultural group, have to come together and have these communications And we as a research company have to work together with the producers and to come up with solutions. And I think we'll come out of this with some more ideas as we move forward. But I appreciate letting me come in and talk and share the story, and I think we're going to come together in a census and have some solutions on some of these diseases.